Reactance in AC circuits is the form of opposition that electronic components exhibit. It is a property of inductors and capacitors. In some respects, reactance in an AC circuit is the counterpart to resistance in a DC circuit. However, there are many differences between the two. Resistance is the relationship of voltage divided by the current through the circuit. There are two types of reactance, one for a magnetic field and one for an electric field. The electric field has a capacitive reactance and is defined by Xc is equal to 1 on 2 pi multiplied by the frequency multiplied by the capacitance in farads. A magnetic field has an inductive reactance and is defined by Xl is equal to 2 pi times the frequency times the inductance, which is measured in henries. As could be seen from the two equations, the main difference between resistance and reactance is that reactance is frequency dependent. As well as this, components that are reactive cause a phase shift, causing the waveforms to be out of sync with each other. As reactance is frequency dependent, as frequency increases, so does inductive reactance, and capacitive reactance decreases. Similarly, when frequency decreases, inductive reactance also does, while capacitive reactance increases. Reactance can be best described using complex numbers, which shows impedance. To find total impedance, we take the resistance of the circuit plus the inductive reactance minus the capacitive reactance. To find inductive impedance, we multiply the inductive reactance equation by J, the complex number, and similarly for capacitive impedance by 1 on J. An example of reactance across an inductor can now be analysed. The circuit shown below has a frequency of 1000 Hz, a resistor of 200 ohms in series with a 10 mH inductor. Following the formula, we can find that XL is equal to 62.83 ohms. Similarly, for capacitance, the circuit again has a frequency of 1000 Hz, a resistor of 200 ohms in series with a 0.74 microfarad capacitor. Again, following the formula for XC, we can find that this is equal to 338.63 ohms. Reactance can be best described.